Hey everybody, this is Mr. Schultz here with you, and we're going to take a look at 712, but specifically, we are going to split this up into 2 days. So this will be our first day of that, and the goal of today is we're going to be taking a look at scatter plots and using them to make predictions. So 712, day 1, let's take a look what this looks like. So this is section 712, what is the relationship? So this is just the first page of 712. Identifying and describing association. When is it reasonable to make a prediction? For example, when you know the height of a tree, can you predict the size of its leaves? Or if you know the outdoor temperature of the day, can you predict the number of glasses of water you will be drinking during the day? In 711, you found that some sets of data were related and others were not. In this lesson, you will look at different situations and decide if they show relationships that allow you to make predictions. As you work with your team today, use these focus questions to help direct your discussion. First focus question is, when one value goes up, what happens to the other one? Is the relationship between one thing changing and the other thing changing? Or is there a relationship between one thing changing and the other thing changing? Can you make a prediction? So let's see what this looks like. So starting on question 7-11, and that question reads, the students in Miss Carly's class, or Miss Carly's science class, have been experimenting with different factors that they think may affect how tall a plant will grow. Each team planted seeds in several pots using different experimental conditions. So to continue on with 711, with your team, read the questions that the students investigated and write your team a prediction for the result of the experiment. Assume that all of the variables are controlled, meaning that the things like that basically outside factors are not going to impact the experimental outcome. So you can write your hypothesis or your prediction that so that it indicates if there's a direct relationship between the independent and dependent variables. So part A says this: does the amount of fertilizer affect the plant? So instead here, if you think that it's going to, you would not just write yes. We want to write it so that there's a direct relationship between the independent and dependent. So we'd write it as something like, the more fertilizer there is, the taller the plant will grow. So talking about both of the variables here, the amount of the fertilizer and the height of the plant. Why don't you try it for these other three, or for these other four, and decide, do you think that these things are related or not? I'll give you a second to pause the video, and then I'll show you what I came up with. All right, so here were my predictions. It says, does how deep the seed is planted affect the height of the plant? I thought that the deeper the seed is planted, the shorter the plant will be. Part C says, does the number of seeds in the pot affect the plant height? I thought that the more seeds in the pot, the taller the plant will be. I kind of went back and forth on this one, but I feel like it just gives more opportunity there. Part D says, does the size of the pot affect the height of the plant? I thought that the larger the pot, the taller the plant will be because it's got more space to put down roots. And part E, does the number of hours of sunlight per day affect the height of the plant? I said the more hours of sunlight, the taller the plant will be. So these are just my predictions. I'm not sure if they're right or wrong yet. So let's see what the data looks like. So looking at question 712, this is where we get into some of the data. After 3 weeks, the teams measured the heights of their plants and recorded the data. The team 1 data table and the question team 1 investigated are included below. On graph paper, make a scatter plot for the data gathered. Be sure that you clearly label your axes, mark the scale at equal intervals, and title your graph appropriately, such as with the experimental question. So here is Team 1's data that's based off the amount of fertilizer. So we want to try to create this graph using these 1, 2, 3, 4, 5, 6 points. So let's take a look at this. So I'm going to say that the height of the plant that in centimeters. So my height in centimeters is going to be on my y-axis. I'm going to say that my fertilizer in milliliters is going to be on my x-axis. And so when I look at this, I see that I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 blanks here. I'm trying to get out to 30, so I might just even add 1 and say, okay, maybe I'll count by 2s, because then that'll put me out to 15. and then I'll be able to count by 2s to get out to 30. So I might do something like that, and then I will go, and I'm just going to count by 2s here. So my scale is going to be 2, 4, 6, 8, 10. Then I like to skip count, so I will just jump a couple of numbers here, just because I think that it just makes my graph a little bit easier to read, and I'm a little bit lazy. Now the height. The height looks like it goes from 14 to 40, so I need to get at least up to 40 on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 again. So I'm not really sure there's a great number that fits into there. So let's just try counting by 5s. So we'll just go 5, 10, 15, 20, 25, 30, 35, 40. It's not the world's greatest scale because I'm losing a bunch of the data up top there. But let's just see what that looks like here. So here, I'm going to take my first piece of data. My first piece, I'm starting at 5, and I go up to 14. So I'm going to go over here to 5, which should be right over here, and then we go up to 14. I'm guessing that's going to be somewhere close to that kind of 15 mark there. So I'm going to 5, and then 14. And then I'm just going to keep doing that for all the rest of these points. So I'm going to pause the video here and do that. Why don't you go and graph all the rest of these points on your graph as well, and we'll come back and we'll compare after that. All right, so here's our graph. So from this, you can kind of start to see and maybe start to make some sort of predictions here and saying, hey, it looks like it's kind of trending up here. It looks like it's kind of going up. So basically, as I'm adding more fertilizer, I'm adding more height. So our first original prediction there seems to be true based off of the data. As I add more fertilizer over the 3 weeks, my plant does seem to be getting taller. We're going to talk about 4 more situations as well as this one and get into some more details and kind of some vocab on day 2 here. But big thing, we just kind of make this graph, practice making that, plot these points, and then we'll get into some details and kind of, okay, now what do we do with this? How can we make predictions with this data here? And that's it. Have a great rest of your day.